To do these problems, even though I thought I would do some yesterday, but I couldn't. Okay, let's start off with this first problem. Find all positive integers n for which 3n minus 4, 4n minus 5, and 5n minus 3 are all primes. Okay, since they're asking find all positive integers, right? So whenever the question is find all positive integers, so the chances are you're not going to have an infinite number of solutions. You probably would find only fewer number of n's. So let's see what is the simplest approach. Well, what happens when you have n equals 1? Some of them are negative, right? For instance, 3n minus 4 is negative 1. This becomes negative 1. And this becomes negative 1. And this becomes 2. So n equals 1 does not give you positive integers, positive numbers. So there's no question of being prime. But when n equals 2, what happens? This is what happens when n equals 1. Okay, when n equals 2, what happens? N equals 2, 6 minus 4 is 2, 8 minus 5 is 3, and we know this is 7. So these are all primes. So n is equals to this might be possibly a solution, right? But we don't know if this is the only solution or are there more solutions, and if not, how do we show that this is the only solution? So think for a moment. What is it do you know about primes? What is it that do you know about odd primes? And what is it you know about even primes? Odd primes, all of them are odd primes. All primes are odd except one even prime. And what is that even prime? That is going to be 2. This is the lonely even prime. This guy doesn't have any friends. Lonely even prime. He's the only even prime. So can we use that lonely even prime fact to solve this problem? What happens when n is odd? When n is odd, okay, when n is odd, what happens to 5n minus 3? 5 is odd, n is odd, 3 is odd, so odd minus odd is going to be even, right? When n is even, what happens? When n is even, then what happens to 3n minus 4? Oops. 3n minus 4. Because n is even, 4 is even, 3 times n is even, so this even minus even. So this is also going to be even, right? So we found that when n is odd, this is even. When n is even, this is even. So, but the only even prime is 2. So if we let 5n minus 3 equals 2, what happens? What happens? Well, you get n equals 1, right? But n equals 1 is not going to solve. Okay, so this is out of question. But if we let 3n minus 4, let me correct that. 3n minus 4. If we let that equals 2, what happens to n? 3n is going to be 6 and n is going to be 2, right? So that's the solution. And so these are the only possibilities. Why? Because we just showed that when n is even, this one is even. When n is odd, this one, 5n minus 3 is even. When n is even, 3n minus 4 is even. So now we showed with that fact that n equals 2 is the only possible solution to it. All right, I'm going to put a stop to this, and